What up, geometry? Mr. Briggs here. Gonna go through a key for the practice for Unit 1. The big thing here, again, is the justifications. So, second problem here. In the diagram below of trapezoid ABEF, AB is parallel to FE. Whenever you get something, you should mark it on your diagram. So AB is parallel to FE. Oh, come on now. So AB is parallel to FE. Next thing, by the way, whenever you hear parallel, you should automatically be thinking alternate interior angles or corresponding angles, and be kind of thinking about those and looking for those. Next thing we have is that CB bisects angle ABE. So CB bisects ABE. Bisect, another word for that, is cut in half. So when we have an angle bisector, it creates two congruent angles. If you look at your justifications sheet, angle bisector creates two congruent angles. Right there. Okay? So that's another thing that you could be thinking about. You can also mark that on your diagram. Those two angles are congruent. We don't know what they are yet, but I'm sure we will at some point. The measure of angle F is 40. Okay? And the measure of angle FAE is 120. Okay. So, I am missing my stylus today. That's why it's a little bit more messy. So, we need to figure out whether these are perpendicular or not, which means that we need to find the angle measure of ACB or BCE. We need to try to find these angles right here. We're not going to put the perpendicular symbol yet because that might confuse us. We're trying to find these angles right here. So let's start with what we have. First thing I generally try to look for is triangles. So I see that I have a triangle here and it's got two measures. So I can say this. So angle AEF is 20 degrees because we have this triangle right here. 40 plus 120 plus 20 is equal to 180. Next, so I know this angle now. I know that I have parallel lines. And like I said, whenever you hear parallel lines, you want to be thinking alternate interior angles. So I see this 20-degree angle, and I see that it is alternate interior to this angle up here. Okay, so this angle and this angle are alternate interior angles. We have two parallel lines cut by a transversal. The giveaway is generally the Z shape. Oh, Z shape. I missed my stylus. So Z shape, this angle, and this angle are going to be congruent. So you will say this. So now we know that that angle is 20. Oh, they also told us that the measure of angle DBE is 40. I forgot to mark that one. Okay, so that's 40 right there. And I'm seeing another Z shape. So that means I have another set of alternate interior angles. Except this time, this entire angle and this entire angle are the alternate interior angles. So this whole angle is 40, which means that this angle is 20 as well. So I'll get the justification down for that. Okay, so BEC equals 20 because parallel lines create congruent alternate interior angles. Now, this next part is a little bit tricky. Right here, you have this triangle, BAC, this triangle, BEC, but you also have triangle BEA, this big triangle right here. So we can find out what this whole angle is because this angle is 20 and this angle is 20 as well. So we can figure out what angle ABE is. There you have it. This whole angle ABE is 140. Now, here comes the part about the angle bisector. If the whole angle is 140 and BC cuts that angle in half, how much is each piece? Well, each piece would have to be 70 because you're cutting it in half. Okay, so I'm going to put in the reasoning for that. Here we go. There you go. So ABC, which is this angle, equals EBC, which is this angle, and they both equal 70 because an angle bisector, if you have an angle bisector, then you have two congruent angles. I literally just copied and pasted that from the angle bisector part of your justifications page, which should now be on your website. So now, that angle 70, that angle 70. Our original question is, what is the measure of this angle and this angle? Well, using the triangle sum theorem, we can figure out that this angle is 90 and this angle is 90 because this is 20 and that's 70. 20 and 70. Both of those equal 90, so that means that this must be a 90-degree angle and this must be a 90-degree angle. So let me put in the reasoning for that. And there you have it. Those are 90 because of the triangle sum theorem. I only needed to state one because if one's 90, then the other has to be 90. And BC is perpendicular to AE, which was our original question, because perpendicular lines create 90-degree angles. So there you have it. All the steps that you would need, nice and organized, along with all of the justifications. Now on to step 2, or question 2. In the accompanying diagram of parallelogram ABCD, DE is perpendicular to AC, which means that we know we have right angles here. We have DE, and that's a right angle, and that's a right angle. I don't like putting both. I only like putting one. We might end up using the other one, but we'll see. Okay, the measure of BAC is 40. And ADE is 70. Okay, we need to find the measure of angle B. I'm going to put that in gold because that's my goal. Really wish I had my stylus. Okay, give a reason for each calculation. We need to find angle B. I'm seeing right now, I'm thinking triangle sum to try to get there. I'm thinking maybe opposite angles to try to get there. I'm also seeing a triangle here. I'm seeing that we have a parallelogram, so alternate interior angles for sure. Bunch of different ways that we might be able to get this. So let's just work with the triangle. It's the easiest thing. It's what everybody knows, so might as well work with it. So, angle, let me put in an equation here. Angle DAE equals 70 plus 90 is 160. So DAE is 20 because of the triangle sum theorem. And we had 70 and 90 as our givens, so 20 must be the third. Alrighty, so now that one is 20. I'm going to draw that one in. I'm also going to move my face over to here. Okay, so that one's 20 now. I still need to figure out a way to get into this triangle over here. Well, since it's a parallelogram, I know that opposite sides are parallel. So that means that this side is parallel to this side. And this is a transversal. So I know that this angle is also 20 because parallel lines create congruent alternate interior angles. Let me write that. Alrighty. So, didn't do this last time because we didn't have a parallelogram, but this time we do have a parallelogram. So I went to my justifications page. I saw that we have a parallelogram, and I used this rule because it has alternate interior angles. So in a parallelogram, opposite sides are parallel, and parallel lines make congruent alternate interior angles. I literally just copy and pasted. And for you, you'd be writing it onto paper and trying to internalize that as well. Okay, so that one's 20. Now we got 40 here, 20 here. We can figure out what angle B is. So there you go. Angle B is 120 because triangle sum theorem states that all of them add up to 180. So 40 plus 20 equals 60. Subtracted from 180 is 120. Now, there are other ways that you could have done this. You could have used a different set of alternate interior angles. You could have used, let's go with green here. You could use this set to get this angle. And since you know this angle and that this angle is 90, so this would be 90, 40. That would mean that this is 90 and 40 is 130. So that would mean that this is 50. 70 plus 50 is 120. And those are opposite angles. So let me type all that out in case you did it that way. Here's the other way that you could have done this. I also forgot to say that those angles were 90 right here. So you do have to put that. So I would say that those angles are 90 because of perpendicular lines. DCA is 40 because in a parallelogram opposite sides are parallel and parallel lines can make alternate interior angles congruent. So this angle would be 40. This angle, EDC, would be 50 because of the triangle sum theorem. And then angle B would be 120 because opposite angles are congruent in a parallelogram. And we can see that this whole angle is opposite of this whole angle. So 70 plus 50 equals 120. Okay, there's that one. So on to the last one. In the diagram, ABCD is a parallelogram. A, B, C, D. BE is congruent to BA. BE is congruent to BA. So already I'm seeing right here we have an isosceles triangle. It has a triangle, two congruent sides. I know that we are going to get two congruent angles. It's going to end up being this one right here and this one right here. BF bisects angle ABC. So that means that BF cuts ABC in half. So this angle is congruent to this angle. If the measure of angle E is 50, then we need to find the measure of AFB. So I'm going to put this one in green. That's where I'm trying to go. AFB. Alrighty. So, first things first. I have this angle right here. It's an isosceles triangle. So that means that this angle up here is also 50. Let me put that in pink. This one is also 50. I'll throw the reasoning on. Okay, so we know that EAB is 50 as well because it's an isosceles triangle. Therefore, we have two congruent angles. Now that we have those two angles, we can figure out what EBA is. Pause video, see if you can find out EBA and why. There you go, it's 80. So now, the way that these generally work is they generally lead you on a path towards the correct answer. So, I know that this angle is 80 and that this angle is bisected. So I know that I can get this whole angle because I have a linear pair. And once I get this whole angle, I can find out each part. So I'm going to do that. So that whole angle was 100 because linear pairs are supplementary. And then ABF is congruent to FBC, and they're both equal to 50 because an angle bisector creates two congruent angles. Now, from here, there's a couple different places you could go. You could just say that we have alternate interior angles, and that's what I'm going to show next. You could say, well, since this is 100, then that means this is 80 because I have a parallelogram and my consecutive angles are supplementary, and that means that this one is 80, and 80 plus 50 is 130, so this has to be 50. Bunch of different ways you can do it, but you guys need to be looking for alternate interior angles. Really, that's going to be one of the big things this year. So I'm going to put alternate interior angles. So angle, again, the way you do that is hit that button. So angle, \angle, AFB equals 50 because, and I could just copy my answer from above, in a parallelogram, opposite sides are parallel, and parallel lines make congruent alternate interior angles. Boom, done. I found angle AFB. So I could put a little 50 in there, and I win. So that's how you do these problems. You work right nice, neatly in order. If you're handwriting this, you still work nice, neatly in order. Use your justification sheet. Do the physical version of copying and pasting. Literally just look at your screen and write it down until you start to get in the habit and you know what to look for. Practice up, ask questions, and be well, geometry friends.